Bismillahirrahmanirrahim. Hello students, welcome to the electrical engineering channel. So this lecture is the continuation of the course of numerical methods with MATLAB, and in this lecture I am going to start the topic of integration. So we will ultimately move to numerical integration later, but in this lecture I will just give the basic idea of integration. Integration stands for finding area under the curve. So the definition of integration is that integral from a to b f of x dx, which gives us the area under the curve from a to b along the x-axis. And the symbol, this is the symbol for the integral, and a and b are the lower and upper limits respectively. F is the function which has to be integrated, and it is called as integrand, and x is the variable of integration. And in integration, we also come across a theorem which is called mean value theorem. And mean value theorem is actually the integral of f of x dx from a to b, and after dividing this answer by b minus a, we will get the mean value, right? So this is the function y is equal to f of x, and this function is defined from a to b, and the mean value of this function will lie somewhere over here. So this is the mean value of this function in the domain from a to b, and this mean value can be evaluated by dividing this integration by 1 over b minus a. So the total range along the x-axis is actually divided, and we will get the mean value. So for example, if we have discrete numbers and we want to get the mean value of those numbers, then we actually add all those numbers, and then we divide the sum with total number of objects, right? So that gives us the mean value for discrete objects. But if we have a continuous function, then the mean value will be evaluated by this mathematical expression. So if area under the curve y is equal to f of x is exactly equal to the area of the triangle, then at point C, f of c will give the mean value of the function. And in this example, we will come to know how the mean value can be evaluated. So in this example, the function is given as x minus 1 square, and find its mean value over the interval from 0 to 3. So let's integrate this function and divide it by 3. So f every value of f is equal to 1 over b minus a, integral from a to b f of x dx. So this is a simple integration, and after evaluating this integration, the every value will be evaluated as 1. So if we want to check at what value of x this mean value is obtained, then we can put this answer uh, equal to this function, and then we can calculate the value of x. So let's assume that x minus 1 square is equal to 1, right? So then the value of x will be evaluated. So c f of c is equal to 1, c minus 1 square is equal to 1. So after solving this equation, we will get two values, 0 and 2. So at x is equal to 0 and at x is equal to 2, the answer will be equal to the mean value, which is 1. So let's solve another example, and in this example we have to evaluate the area of this shaded region, and this is a complete circle and its radius is equal to 1, and the equation of the circle is equal to x square plus y square equal to 1. And let's calculate the area of this shaded region. Now from here we can uh, rearrange this equation, and after rearranging this equation, y square will be equal to minus x square minus 1, and y will be equal to plus minus 1 minus x square under root. So y equal to 1 minus x square under root is actually the equation of this upper semicircle, and y is equal to minus square root of 1 minus x square will be the equation of this lower semicircle. So since this shaded region is lying in the upper semicircle, so we will use this equation y equal to 1 minus x square under root. So let's integrate this from 0 to 1. So a equal to 0 to 1 integral 1 minus x square under root dx. So this integration can be evaluated easily by substitution method, and x is equal to sine theta, dx is equal to cos theta, d theta. Put the substitution in this equation, it will become 1 minus sine square theta integral cos theta d theta. So 1 minus sine square theta under root is equal to cos theta. Cos theta into cos theta is cos square theta d theta. So cos square theta is equal to 1 plus cos 2 theta over 2. So this is 1 by 2 integral plus cos 2 theta over 2 integral d theta. And the integral of 1 by 2 is theta, and integral of this expression is 1 by 4 sine 2 theta. Let's put these limits. And the area will be equal to 1 by 2 theta plus 1 by 4 sine 2 theta. And theta is equal to sine inverse x from this equation. So let's do the back substitution, and it will become 1 by 2 sine inverse x, and sine 2 theta is equal to 2 sine theta cos theta, so it will become 1 by 2 sine theta cos theta. So this value of sine theta and cos theta can be evaluated from this triangle, right? Since we have sine theta is equal to x, so it means this is x and 1 is the hypotenuse, because sine theta is equal to perpendicular over hypotenuse. So this is x and 1 is the hypotenuse. So base is equal to 1 minus x square under root, and this angle is theta. So from this triangle we can calculate the value of cos theta. So cos theta is equal to 1 minus x square under root divided by 1. So it is 1 minus x square under root. And let's put the values of sine theta and cos theta in this expression. So sine theta is equal to x. So here we have x, and cos theta is equal to 1 minus x square under root. Now let's put this limit. So after putting this limit, this expression will be equal to 0, and this expression will be equal to 1 by 2 sine inverse 1. And we know that sine inverse 1 is equal to pi by 2. So it will be equal to pi by 4. So this is the area of the this shaded region, which is quarter circle. Let's solve another example, and in this example we have to evaluate the integral of this expression. So this expression can be written as 1 over cos square x plus sine x over cos square x, integral from 0 to pi by 4. So this is secant square x, and this is equal to secant x tangent x. The integral of secant square x is tangent x, and the integral of secant x tangent x is secant x. So let's put these limits, and it will become 1 minus 0, and this will be under root 2 minus 1. So the final answer is 1.41. So these are all simple integrations, and I hope you have understood the concept of integration. For watching more lectures, please subscribe this channel. Until the next lecture, it's goodbye.